Here are the answers for 10.4 Part 2. Pause the video if you need to look at these a little bit longer. Today we're going to look at quadratic inequalities, and I apologize, my notes kind of jump back and forth between examples, so we can rename these examples if we need to. With quadratic inequalities, really what we need to do is find critical numbers and then test numbers around the critical numbers to figure out where the real solution is. So you're going to hear me talk a lot about critical numbers. With quadratic inequalities like this, to find the critical numbers, the first thing that you need to do is get 0 on one side. And then you need to factor and solve. You need to figure out how to solve, if that was like an equation that equaled 0, factor it and solve it and get those solutions. Those solutions are the critical numbers. And then we are going to test around the critical numbers to determine the range of solutions that are going to work for this original inequality. So step number 1, I need to get 0 on one side. So this is x squared minus 25 is less than 0. Now you can, I like to factor and solve this. You could solve this with square roots without getting 0 on one side, but you need to solve this. You need to get the solutions as if this was an equation. So I would solve this by factoring x plus 5, x minus 5. So that means the solutions are -5 and +5. These are our critical numbers. Excuse me. Okay, the testing stage. We're going to make this little table, and I'm going to put -5 and +5 on here. Think about this as like a number line. I want to test the numbers around -5 and 5 to see if the numbers smaller than -5 work in the original inequality. Do the numbers between -5 and 5 work, or do the numbers bigger than 5 work? So less than -5, you could try -6, you could test -7, you could test -10. You can pick any number that you want that is smaller than -5. I am going to test -6, okay? So if I put -6 into this original thing, -6 squared, and I'm testing to see, is that smaller than 25? -6 squared is 36. Is 36 smaller than 25? No, it is not. So this is a big no. The numbers smaller than -5 do not work in this original inequality. Now let's test the numbers between -5 and 5. I'm going to test 0 because I think that 0 would be an easy number to plug in. So 0 squared minus 25, I should write this in something thinner so I can actually see it. 0, ooh, that does not show up on that background. 0 squared, we want to see if that's less than 25. Is 0 less than 25? Yes, it is. Now let's test a number bigger than 5. Like you could try 6, 7, 10, 12, 100, whatever number you wanted that was larger than 5. I'm going to test 6. 6 squared, is that less than 25? No, it is not. So this is the area that we want to focus on. The numbers between -5 and 5 are going to work. Now, how do we write that? We want our x values to be in between -5 and +5. So x needs to be bigger than -5 and smaller than 5. -5 is less than x is less than 5. If you're doing interval notation, that would be -5, 5. In example 3, we already have one side equal to 0. We need to factor and solve. So this is going to factor. We need two numbers that multiply to give us -6 and add up to -1. That would be 2 and 3. And to make it -1, that would have to be a -3 and a +2. So if this was x plus 2 times x minus 3 equals 0, we would solve this by saying that our solutions are -2 and +3. Those are the critical numbers. We need to test the numbers smaller than, in between, and larger than these numbers. So I'm going to make myself a little table, -2, 3. Okay, we need to pick a number smaller than -2. I'm going to pick -3. And we need to plug this into this original problem. So actually, I need to move these out of the way, don't I? There we go. Okay, so if I'm testing -3, we need to test it in the original problem. -3 squared minus -3 minus 6. We want to know if that's greater than or equal to 0. -3 squared is 9. Minus a -3 would be +3 minus 6. We can do that in our calculator. 12 minus 6. Is 6 greater than or equal to 0? Yes, it is. Now let's test a number in between. What number do you think would be good that's in between -2 and +3? 0. Anytime you can test 0, test 0. It's an easy number to plug in. 0 squared minus 0 minus 6. 0 squared is 0. Minus 0 minus 6. Is -6 greater than or equal to 0? No. Now test a number bigger than 3. I'm going to test 4. You could test 5, you could test 6, anything that's bigger than 3. So 4 squared minus 4 minus 6. 4 squared is 16. Oops. And that would be 6. Is 6 greater than or equal to 0? Yes. So we want numbers smaller than -2. We also want the numbers larger than 3. So our x values need to be less than or equal to -2, or our x values need to be greater than or equal to 3. Sorry about all the background noise. My daughter is apparently telling a very interesting story to my husband. Now, why did I use less than or equal to, where in the previous example I just used like less than without the equal to line? So in this example, the original symbol did not have the equal to line. So we did not include the critical numbers in the solution. In this example, the original symbol has that or equal to line. So we are going to include the critical numbers in the solution. So our solutions are x is less than or equal to -2 or x is greater than or equal to 3. Okay, here's one more quadratic. The first step we're going to do is to get 0 on one side. And I would like you to pause the video and try this one on your own. Factor and solve to get your critical numbers. Test around those critical numbers and see if you can figure out what the solution would be. Hopefully you paused the video to get to this point. You should end up with 2 and 5 as your critical numbers. Now, this time 0 isn't in between our critical numbers. 0 is actually over here. So I am going to test 0 in between 2 and 5. You can pick any number, 3 or 4. I'm going to test 3. And then bigger than 5, I'm going to test 6. Now remember, you're testing them back in the original problem. So pause the video again, test those numbers, whichever numbers you picked, and then we'll see if we can figure out the intervals that include our solutions. Okay, so I tested my three numbers in the three different ranges, and I found that numbers smaller than 2 don't work, numbers between 2 and 5 work, numbers bigger than 5 don't work. So this is the range. We want these numbers that are in between 2 and 5. So our solution is the numbers in between 2 and 5. 2 is less than x is less than 5. And then look back at the original solution, or the original symbol. The original symbol was less than or equal to, so we are also going to include those critical numbers in the solution. So 2 is going to work, 5 is going to work, and all of the numbers in between 2 and 5 will work. Okay, this is kind of a side note. This is not a quadratic inequality, but these are inequalities that you solve basically in the same way. To get your critical numbers, you want to look for where the top equals 0 and where the bottom equals 0. So you might want to write on here that the critical numbers come from where the top equals 0 and where the bottom equals 0. So in this particular example, the top would equal 0 when x was 0. So our critical numbers are going to be 0. And then where would the bottom equal 0? When x is positive 2. So our critical numbers are going to be 0 and 2. 0 and 2. We want to test numbers in between and around those critical numbers. So I'm going to test -1. I'm going to test +1, and I'm going to test 3. And you're testing them back in this original problem. So -1 over -1 minus 2, we're going to see if that's greater than 0. That is -1 over -3, which would be +1/3, and yes, +1/3 is bigger than 0. So yes, this range works. If we test 1, that'd be 1 over -1, which is -1. -1 is not larger than 0. Test 3. 3 over 3 minus 2. Is 3 greater than 0? Yes, it is. So we are looking at x values that are smaller than 0 or x values that are larger than 2. Okay, I'm skipping over this one. Actually, we're just going to change this one. We are going to change this one to 7 over x minus 3 is less than 0. First step, find the critical numbers. Our critical numbers would be where the top equals 0. Well, the top is 7. The top is never going to equal 0, so there's not a critical number there. Our other critical number is where the bottom equals 0, and that would be 3. So our only critical number is 3. That makes the testing a whole lot easier because we only have to test two things. We need to test something smaller than 3. I'll test 0. We need to test something bigger than 3. I'm going to test, you can test 4, 5, 6, whatever you want. Okay, so 7 over 0 minus 3. That would be a negative number, and a negative number is smaller than 0, so yes. If we test 4, that'd be 7 over 1. 7 is not smaller than 0, that would be a no. So the numbers smaller than 3 are going to be our solution. So our solution is x is less than 3. Okay. Here's your assignment for section 10.6.